Hello everyone, and welcome to the final lecture in this week's content. In this video lecture, we will discuss ecological inference, ecological fallacy, and also overview a brief introduction in how we define and measure our concepts in our research. Okay, lastly, I've got some follow-up material. This is all stuff that we've talked about pretty extensively already. So units of analysis, right? A good hypothesis will always indicate what level of phenomenon is going to be measured, the level at which observations are made. So you guys should be super familiar with this by this point. Most common units of analyses are cities, elections, and counties. So here's an example of some hypotheses that clearly state the unit of analysis. Another thing to keep in mind, this part's a little complicated, are some potential problems that can occur with cross-level analyses. So in a cross-level analysis, data is collected for one unit of analysis, and then it is used to make inferences about another unit of analysis. And really, this is something that all of us are doing to some extent or another in our research papers. If you're interested in studying voter behavior, right, and how like certain characteristics of a population might influence voter turnout, well, we have the secret ballot in the United States. Like, we have no idea of truly understanding how every single American votes, and how different aspects of their background, right, their formal education or what, we have no idea like what impact that precisely has. The best we can do is make ecological inferences. We use data at the aggregate level to make inferences about the individual. Now, this is a good thing. We try to make ecological inferences. So, for instance, if 80% of one state has a college degree, and we see that 90% of people in that state vote, and then we see that other states with like 5% of the population has a college degree, and I'm just making up ridiculous numbers here, 0% of people in that state vote. And we see these patterns across entities, right? We might assume that there is some relationship there between how much education the population has and whether or not they go out and vote, right? So that's the primary characteristic of an ecological inference. In most cases, we don't have perfect data, so we have to make an inference or an assumption about the relationship that's really going on there. Ecological fallacies, on the other hand, that occurs when there's a relationship among groups, and then we argue that group level relationship exists at the individual level when it actually doesn't, right? So these are big no-nos, big things we don't want you to avoid. You might be thinking to yourself, oh my god, this makes no sense to me. What the hell is an ecological fallacy? Well, you're in luck. I have an example for you. And then I promise there's just a few more things I want to talk about. So we're going to talk about what ecological fallacies are, a very, very brief introduction into the week 4 material, and then we'll wrap up the lecture. So first of all, I just want to highlight how all of us will be engaging in ecological inference, right? We have to rely on data at the aggregate level, like a state or a school district or something, in order to make inferences about the individual. So if our research question wanted to examine the relationship between students with subsidized lunches and whether or not students with subsidized lunches had specific test scores, well, we could easily look at national surveys of school districts and get this data and make inferences about the relationship between the two. Are poor children more likely to die from childhood diseases? Well, there is a ton of data out there that measures all of these things. We don't necessarily have specific individual level data for every single American in the country, but we can make inferences. And then lastly, are lung problems related to air pollution? Again, we don't have data on every single American in the country who has lung problems, but we do have access to air pollution indices in major metropolitan cities, and we could compare, do cities with higher pollution, with higher air pollution, do we also see higher cases of lung problems in those areas. So all we can really do is, make those inferences, make those assumptions, okay? So now let's talk about how things can get problematic with our ecological fallacies. So assuming that a relationship exists at the individual level just because a relationship exists at the group level. So let's say that this is our hypothesis. Democrats are more likely to support a sales tax increase than Republicans. There's a lot of literature and theory to support this. We know that Democrats generally favor larger government, and Republicans largely favor small government, less taxes, things of that nature. So we collected some data. We've got vote returns in Precinct 1 and Precinct 2. So this is an example straight out of your book. Let's see. This is on page, I think it starts on page 118 of your book if you're interested, but this is an example that I just stole right out of your book. So we've got voter returns in Precinct 1 and 2 for whether they supported or opposed the sales tax. And then we've also got data on the proportion of Democrats and Republicans in each precinct from like a previous election or something. So our findings, what did we find in our analysis? Well, we know that Precinct 1 has more Democrats based upon the election results in a partisan election, and that precinct also supported the tax by 67%. We also found that Precinct 2 has more Republicans, but they supported the tax way less, by about 53%, compared to Precinct 1 that supported it by 67%. So we might assume that support for the hypothesis has been demonstrated here, and argue that Democrats were more likely to vote for the tax increase than Republicans. So I want you to think to yourself, based upon all of this information that was just presented, has an ecological fallacy been committed? Well, let's look into the data for more details. So we've got two precincts that we're analyzing, right? Precinct 1 and Precinct 2. Let's start with Precinct 1. So here we have a partisan breakdown from an election in one chart, and we have the vote for the tax in the other chart. So these are both aggregate data. It's measured at the level of the precinct, not the individual level. And remember, like I just said earlier, because we have secret ballots in the United States, we don't have actual data on how every single American votes in every single election. The best thing that we can do would be to look at how voters in Precinct 1 voted in a partisan election and compare that to how people voted on the tax initiative. This would give us an estimate of the partisan composition of Precinct 1. So in the partisan election, if that's over here on the left, we found that 50% of voters in Precinct 1 voted for the Democrat, 20% voted for the Republican, and 30% voted for a third party. So the precinct seems mostly Democrat. Now imagine we want to compare this aggregate data from the partisan election to the results for the vote on the tax initiative. And we see that 67% of individuals voted for the sales tax. So because, here's where the inferences and the assumptions can get a little shady. Because the district is mainly Democrat, based upon our partisan election results, can we conclude that it was also the Democrats who voted to support the tax? Let's look at Precinct 2. In the partisan election for Precinct 2, we find that 50% of the voters voted for the Republican candidate. In some partisan election, right, all of this is hypothetical, 40% voted for the Democrat, and 10% voted for a third party. So we conclude, based upon the partisan election data, that Precinct 2 is mostly Republican. Additionally, when we examine support for the tax initiative in Precinct 2, we find far less support. Only about 53% in Precinct 2 voted to support the tax initiative. That was compared to the 67% from Precinct 1. So what we see here is we're kind of engaging in this logic, right? Precinct 1 has a lot of Democrats in it. They overwhelmingly voted. to support the tax initiative. We know Precinct 2 has a lot of Republicans in it, and they voted, they still voted for the tax, but far less than Precinct 1. So I think, right, this is the error of the logic. Democrats must have been more likely to vote for the tax initiative, and Republicans were less likely to vote for the tax initiative. And this is, in fact, an ecological fallacy. What is true at the aggregate level is not necessarily true at the individual level. So how exactly have we committed such an error? Well, what I want you to do is we're going to pretend that we did have perfect knowledge on how exactly every single individual in both of these precincts voted, and pretend that we have perfect knowledge on their partisanship, and then analyze how we just made an improper inference based upon the data. So pretending that we did have perfect knowledge on which individuals voted for the tax increase in each precinct, we would see our assumptions were wildly off. Let me walk you through these charts real quick. Look at how Democrats voted in Precinct 1. They're essentially in a dead heat with one another. 25 Democrats voted for the tax initiative, and 25 voted against it. And remember, Precinct 1 had the most Democrats in it, and also the highest support for the tax. But our inference about the individual was wrong, because we only had access to that aggregate data that made it look like these two things were related, when in fact they really weren't. And look at this. When we look at Republicans in Precinct 1, we see that all but two Republicans voted to support the tax initiative. And now that we have more nuanced data, we can see that even though the district is mainly composed of Democrats, there's 50 Democrats, right? It was the Republicans and the third party who were most likely to vote yes on the tax in proportion to their groups, right? Almost all Republicans voted yes. Almost all third party voters voted yes. It's the Democrats where things were far less, or way more competitive, right? Equal numbers voting for and against the tax. Well, what about Precinct 2? Here we see that Republicans constitute most of the support for the tax initiative. And that's completely contrary to our assumption that we were making based upon the aggregate level data. So the Democrats in Precinct 2 were far more likely to oppose the initiative. So again, that's just completely contrary to what we expected. Instead of saying that the Democrats were most likely to vote for the tax initiative, this data, again, this fake data, turns all of that completely upside down. So again, if we had perfect data, we would have seen that our assumptions were totally off. And looking at the hypothetical data here, we see that it was actually Democrats who were most likely to oppose the initiative, not support it, and Republicans were the most likely to support it, not oppose it. So the reason that I walk you through this example is because rarely in political science research do we ever have perfect data. In almost all cases of data analysis, we almost always have to rely on some type of inference to make a judgment, or we have to measure one unit of analysis to make inferences about another unit of analysis, and make assumptions about how those variables are related. Hopefully this exercise has been useful in helping you understand how to not make such mistakes. And what I want to leave you with here is, remember, you always have to be really careful about the way that you're reporting your results. If you are making a statement that does not 100% rely on a direct observation from your data set, the best thing you can do as a data analyst is suggest that there may be a relationship between these two variables, right? And always be sure to note what type of analysis would be needed to be 100% certain of the results, right? So if this was a research paper that we were writing, we might say evidence suggests that there may be a relationship between how democratic a precinct is and how they voted for the tax initiative. However, we only have aggregate level data. and individual data would be required to make such an assessment. Like, that's exactly how you cover yourself from making such an ecological fallacy, okay? All right, one final mistake to avoid early in the research process is making sure that you aren't mixing your units of analyses. We can't combine individual and aggregate observations in the same data set because the observations just don't really match up. And they don't really make sense either. So say we had the hypothesis, the more education a person has, the more democratic his or her country will be. Well, first of all, that just doesn't really make any sense. How does the education level of one individual have an impact on the level of democracy in his or her country? And how would we even code that in a spreadsheet? It just doesn't make any sense. And look, we've already talked about this measure of democracy in the United States variable. What do we call that? It's constant. It doesn't even vary. So just make sure that you're not, mixing aggregate levels, measures and individual measures. They don't mix. They don't mix. Okay. We've arrived to the final portion of the lecture, and this is just a very brief introduction into how we define concepts and how much that matters. And all of this will be discussed in a lot more detail next week. So let's go over the basics. Major concepts in political science research seek to describe how people interact with each other and how our political institutions work. Topics like democracy, power, representation, justice, they're all immensely important topics that merit study, but how do we measure that? How do we put justice into a spreadsheet? How do we measure power across different countries? How do we operationalize or measure these topics? Well, based upon the activities we've been doing in this class, this should seem like a pretty familiar exercise at this point. If we wanted to study the impact of gun laws on crime, where do we start? Well, first, we figure out what the main concepts are. In this case, it's gun laws and crime. And once we've got our concepts nailed down, we make sure that there are empirical observations to measure each concept. So in the case of gun laws, we need to narrow the scope, decide what you really want to study here. Are we talking about concealed carry laws on college campuses? Are we talking about firearm registration laws? Are we talking about magazine size restrictions, weapon bans? What exactly are you talking about when you say gun law? And what about crime? There's a million different ways to measure crime. But what are you interested in saying in your research paper? Or do you want to measure home invasions or murder or assault? All of these questions have to be answered by the researcher. We could take another example. What's the impact of economic development and democracy? Again, these are very broad. We need to make it more specific. We need to nail down those concepts and talk about what we really mean. So in this case, the primary concepts are economic development and democracy. So how do we define economic development? Does that mean the country is part of a major trading bloc? Does it mean that the country has a specific gross national product average? What does it mean? And democracy, additionally, what does that mean? Are we talking about countries where all citizens have the right to vote, or are we talking about countries where institutions are governed by a separation of power? And the reason that I bring this up is because the way that we measure our concepts, that has a massive impact on the types of findings that we might have. So we can go over this more next week, but just look at the measurement chosen for, is the country economically developed, right? We could measure that one way, where the country is part of a major trading bloc. So here, countries A, B, C, D, E, and F, yes, they're part of a major trading bloc. Okay, so they're economically developed. But what about that gross national product measure? What if we wanted to use that variable instead? Well, then we see that that only applies to countries A, B, C, G, H, and I. And so notice, just by switching our variables, the way that we measure economic development, where previously we had countries D, E, and F considered economically developed when we were using the trading bloc measurement. Now, when we switch to the gross national product measurement, they're no longer considered economically developed in our data set. So that could have significant impacts on, you know, the type of findings and conclusions that we come to in our research. And the more variables you include and the different measurements that you could potentially obtain for each of those. I mean, just look at how we compare economic development and democracy in this graph. And based upon whichever measurement you choose, that can have dramatic consequences for your data. So if you use the trading block example and variable as economically developed, and then you also use the separation of powers variable for is the country a democracy, right? That's going to limit your analysis completely. I mean, those countries, only 3 of those match up, right? And so you can just kind of play around pretending if you use different measurements for each concept, and you'll get wildly different results. So next week we will talk all about how to properly measure concepts so we can avoid these type of problems when we do our research. All right, well, congratulations, you've made it to the end of this lecture. I know this one was long, but I certainly don't think future lectures will be this long. But there's just a whole bunch that we kind of had to get through today in order to really lay the foundation for the rest of the course. So I'm proud of you for making it through to the end. Just a quick recap. Today we talked about different types of variables, identifying relationships, how to use causal arrow diagrams to understand how our variables are related with each other. We talked about how to articulate theories and hypotheses, the characteristics of good hypotheses, and finally a brief introduction into concepts and measurements. All right, everybody. Thank you so much for tuning into this week's lecture. I hope you learned something. If you have any comments, please post those in the discussion board. As always, stay healthy, stay safe. Thanks for watching, and I'll see you guys on Thursday.